Hello, students. I'm coming to you with the next video lecture on Chapter 3, which covers measures of central tendency and variability. This is the second video lecture in the series. In the last video lecture, we discussed measures of central tendency, which include mean, median, and mode. We also discussed the three different types of means, which include the arithmetic mean, the trimmed mean, and the weighted mean. We also discussed the concept of outliers or extreme scores and their impact on measures of central tendency. And finally, we discussed the concept of levels of measurement and the various ways in which they determine which measures of central tendency are most appropriate to report. In this video lecture, we will discuss the concept of measures of variability or dispersion, which include range, variance, standard deviation, and interquartile range. We will also discuss the concept of box and whisker plots, along with the difference between extreme and minor outliers. And finally, we will discuss best practices for reporting measures of variability. At the end of this video, I will invite you to check for your understanding of these concepts. In terms of learning objectives, by the end of this video, you should be able to understand and explain the concept of range, the concept of variance, the concept of standard deviation, the concept of interquartile range, the concept of box and whisker plots, the difference between extreme and minor outliers, and finally, which measures of variability to report, along with measures of central tendency. As mentioned in the last video lecture, measures of central tendency and variability go hand in hand and are often discussed simultaneously. Both measures of central tendency and variability help us to summarize our data. Although multiple data points are entered into a data set, measures of central tendency and variability are intended to produce a single number that describes the shape of our data. So again, in this video, we will be focusing on measures of variability, which include range, variance, standard deviation, and interquartile range. We will not cover the concept of mean deviation. We use measures of variability to provide a mental image of the dispersion of values within our data set. Dispersion is the extent to which a distribution is stretched or squeezed. Take this illustration as an example. In graph A, the distribution has a high peak, which indicates that most of the values in the distribution are concentrated around the center point or mean. On the other hand, in graph C, the distribution has a low peak, which indicates that most of the values in the distribution are spread out or dispersed from the center point or the mean. Generally, the flatter the peak, the more dispersed the scores are and the more variability there is within the distribution. On the other hand, the more pointed the peak, the less dispersed the scores are or the less variability there is within the distribution. Now let's discuss the concept of range in greater detail. Range is the simplest measure of variability. It encompasses all values within a distribution of scores. The range is computed as follows: the maximum score minus the minimum score plus 1. We add 1 to the difference so that the range reflects all of the values within the distribution of scores. So for example, if we had a distribution of scores that ranged from 22 to 42, we would simply take the maximum score of 42 and subtract it from the minimum score of 22, add 1, and our range would be equal to 21. Now let's discuss the concepts of variance and standard deviation. Variance is a statistic that measures how spread out a distribution of scores is from the mean. It describes the variability among scores within a data set. Calculating the variance is the first step in obtaining the standard deviation. The standard deviation is the most reported measure of variability. It indicates how closely or tightly scores cluster around the mean, which is helpful in describing the distribution of a variable. So let's take these two graphs as an example. In graph A on the left, when the values are loosely clustered together in a distribution and the peak is flat, the standard deviation is large, which means the scores that make up the distribution are very spread apart. On the other hand, for graph B, when the values are tightly clustered together within the distribution and the peak is sharp, the standard deviation is small, which means the scores that make up the distribution are not very spread apart. The standard deviation allows you to make judgments about how representative the arithmetic mean is of the data. The larger the standard deviation, larger standard deviations suggest a high degree of variability in the data and perhaps the presence of outliers. Generally, the larger the standard deviation, the less trustworthy the arithmetic mean. In this case, the arithmetic mean may not be the best measure of central tendency to use for describing data. Now let's discuss the steps in calculating variance and standard deviation. Here is the formula for variance. This slide provides an explanation of each of the symbols included in the formula and what they are intended to represent. S squared stands for variance. X bar stands for mean. Sigma stands for sum. The letter X stands for raw score, and the letter N stands for sample size. To calculate the variance, in step 1, we would calculate the arithmetic mean for the variable. In step 2, we would subtract the mean from each raw score in the distribution, which yields the mean deviation. Finding the mean deviation simply means calculating how much each raw score deviates from the mean, as shown in the illustration on the right. In step 3, we would square each mean deviation. In step 4, we would sum all of the squared deviations. This is called the sum of squares. In step 5, we would divide the sum of all squared deviations by the sample size minus 1. Here's an example of the calculation of variance for the variable life satisfaction. Column 1 includes the raw scores that make up the distribution for life satisfaction. For step 1, the mean was calculated, which is 21.17. As shown in column 3 for step 2, each individual raw score was subtracted from the mean, yielding the mean deviation for each raw score in the distribution. As shown in column 4 for step 3, each mean deviation was squared. At the bottom of column 4, in step 4, all squared deviations were summed. As shown in the blue box below in step 5, the sum of all squares was divided by the degrees of freedom, which is the sample size minus 1. To calculate the standard deviation, simply compute the square root of the variance. As you can see, the square root of the variance or standard deviation is 6.17. Now let's discuss the concepts of quartiles and interquartile range in greater detail. The distribution of any variable can be divided into 4 equal parts, or what is referred to as quartiles. Each quartile makes up 25% of the distribution. The first quartile, or Q1, lies at the 25th percentile. The second quartile, or Q2, lies at the 50th percentile. And the third quartile, or Q3, lies at the 75th percentile. The second quartile, or Q2, is always the median because it splits the distribution of scores into two equal halves, with 50% of the scores on the left side of the distribution and the other 50% of the scores on the right side of the distribution. To locate quartiles within a distribution of scores, we would need to do the following. First, arrange the data in an array from the lowest score to the highest score. Second, split the distribution into two equal sets of scores. And third, find the median for each set of scores. Here's an example for the variable life satisfaction. In the box below, as you can see, the distribution is broken up into two equal sets of scores. The median for the first set is 28, and the median for the second set is 36. The median for the overall distribution is 32. So Q1 equals 28, Q2 equals 32, and Q3 equals 36. Interquartile range is defined as the distance between the 75th percentile and the 25th percentile. This is another measure of variability. Interquartile range is symbolized by IQR. The formula for IQR is Q3 minus Q1. So in our example for the variable life satisfaction, the IQR equals 8. Now let's discuss box and whisker plots. Box plots are used to display measures of central tendency and measures of variability. They include the following information about a distribution of scores: the median or Q2, the range, which includes the minimum score and maximum score, the quartiles, which include Q1 and Q3, and the interquartile range, which is Q3 minus Q1. Box plots are useful not only for providing a complete image of a distribution, but also for identifying outliers within a distribution. To construct a box plot, we would need 5 numbers, which is also called the 5-number summary. These 5 numbers include the minimum score, the 25th percentile or Q1, the median or Q2, which is the 50th percentile, the 75th percentile or Q3, and the maximum score of the distribution. Here's an example of a box plot for the variable life satisfaction. I draw your attention to the top of the graph where the outliers are pictured. These are the scores that fall on the extreme ends of the distribution. You might be wondering what the numbers are next to each of the dots. The numbers next to each dot represent the case number within the data file. So we would be able to simply return back to or refer back to our data set in order to find case number 15, case number 8, case number 16, case number 13, and case number 23. By going back to our data set and referring back to each of these case numbers, we can identify where the outlier scores are within our distribution. So again, box plots are useful not only for providing a complete image of a distribution, but also for identifying outliers within a distribution. Now let's discuss the difference between extreme and minor outliers. There are some outliers that are considered to be extreme and others that are considered to be only minor. There is a specific formula that we utilize in statistics in order to determine which outliers are extreme and which ones are minor. Any score that is greater than or less than 3 times the IQR is considered to be an extreme outlier. And here are our extreme outlier formulas. On the other hand, any score that is greater than or less than 1.5 times the IQR is considered to be a minor outlier. And we will discuss how to go about calculating extreme and minor outliers during our class sessions. Now let's discuss the best practices for reporting measures of variability. When describing our data, we typically report measures of central tendency along with measures of variability. But there are some best practices to consider in terms of how we go about pairing these measures together. The mode is generally reported along with the range. So for example, we might say that scores range from 0 to 40, with the most frequently reported score being 20. The mean is generally reported along with the standard deviation. So for example, we would report that our mean is equal to 50.50 and our standard deviation is equal to 5.75. Reporting the two numbers together enables the reader to get a clear picture of how the data are distributed around the mean. Specifically, whether the data are tightly clustered around the mean or widely dispersed from the mean. And finally, the interquartile range is generally reported along with the median. Reporting these two scores together help to counteract the distorting effect of outliers because they only consider the scores in the middle of the distribution. Here's a summary of what we've just discussed. While these are not the only combinations to consider, this is at least a starting point that is intended to get you thinking about how to best pair these measures in a way that provides the most accurate and useful representation of the data. So in summary, in this video, we have discussed measures of variability, which include range, variance, standard deviation, and interquartile range. We have also discussed the concept of box and whisker plots, as well as how to identify extreme and minor outliers. We ended our discussion by identifying some best practices for reporting measures of variability, along with measures of central tendency. This is the point at which I invite you to check for your understanding of these concepts. You can do this in one of three ways. You can either complete the form on the left and simply click submit, or you can copy and paste the link into your browser or scan the QR code with your cell phone in order to complete this form. Here is a crash course video on measures of spread or variability that you might consider watching in your own time. I hope this has been helpful, and I look forward to seeing you in the next class.